Hello students, again welcome to the class. In the today's class we are going to start the new concept of your chapter, that is nothing but the addition of velocities. So in the today's class we are going to find how the velocities are added with respect to the different type of frame of reference. Okay, as already we know, two frame of references will be there, isn't it? So if I want to tell those, I am drawing here. One is S frame and the another one is nothing but the S dash frame. So its coordinates are x, y, z, and its coordinates are x dash, y dash and z dash. Okay. Then when we are having two different type of frame of references, one is S and another one is S dash, something event will be happening at the what? S dash frame. The event may be anything. Okay. So when the event is happening at the S dash frame, there are two observers. One is there in S frame and another one is there in a what? S dash frame. And both these observers are observing the same event. Okay, so when both the observers are observing the same event, then whether the event seems to be same for both the observers or it will be different, that is our question. And for that question we got the answer also. So already we started the chapter. While starting the chapter, I told you three cases we had there. Okay, so the first case is nothing but if light is propagating from the this point. So when light is propagating, then how it will be looking for this observer and this observer. And the same time, in the first case we taken a rod. Here we taken a rod and its length has been measured from the first person as well as with the second person. Means first person, when he observed, when he calculated the length of this rod, at the same time the second person, when he calculated the length of the same rod, it will not come the same value. They are coming a what? Different value. The reason is the S dash frame is moving along the what? Positive direction of the x-axis, whether the S frame will be at a what? Rest position. So this is at a rest position, but the second frame, whatever is there, it is under motion like this. So when it is moving, the object which is there inside that one also it is moving. So when both these are moving, so what happens for the second observer, the length if he calculated, then it will be more than the first observer. That is vice versa. What we can tell, the first observer, whatever he calculated the length, it should be less than the what the length observed or the calculated by the second person. The thing I want to say here, the whatever the length we calculated, the two persons who are in the two different frame of reference, their calculation will be what? Different. The length they will got what? Different length they will got. The reason one frame is at rest position and the other frame will be at a what? Moving position with respect to the x-axis. So this is the first case we studied. In terms of what? Length. Okay, so that is called as what? Length Lorentz transformation equation. And the second thing, if any something event will be happening, then what will happen? Both the observers will calculate at that time. So when the event started, that it will be T1, and when it will be finished, it will be T2. So that difference they will calculate how much time an event taken to complete that. Okay, so when they calculated that time difference, here also the first observer, what he will get that time difference to happen that event, he will not get the same thing for the second observer. Okay, so that time also same event, but when observed by the two different persons, then they are getting a what? Different values. So that one we called it as what? Time dilation. So that is nothing but what? Time dilation. So in the last class I derived the time dilation equation. Okay, and in the today's class we are moving to the third point, that is nothing but what? See here, S frame again it is at a rest position and S dash frame it is under motion. So when it is moving, here something object is there, and that object is also under motion, it is also moving, okay, with respect to x-axis only. So when it is moving, the second person will calculate the velocity of that, because already you know whenever a body will be moving, it must have the what? Velocity. It must contain the velocity. So now as this body is moving means it is having a velocity. But what will happen? Here first observer will calculate that velocity, that is phi x. So phi x is the velocity of a body calculated by a what? First person. At the same time, the second person will also calculate the velocity of a body, and that one we will note down by what? Phi x dash. Understanding? See, two different frame of references are there. One is S frame, another one is S dash frame. S frame is at a rest position, it is not under motion, and the S dash frame, it is moving along the positive direction of the x axis. Now our event or our case is, here one body is there in a S dash frame, it is also moving with respect to what? S dash frame, it is under motion in the S dash frame. So when it is moving, as it contains the velocity, that velocity will measure by the first person and he will name it as what? Phi x. At the same time, the second person also measures the velocity of that body and he will name it as what? Phi x dash. Okay. So phi x is the velocity of the body when it is calculated by the observer who is there in the S frame. And phi x dash is the velocity calculated by a person who is there in a what? S dash frame. That's what the difference. Okay. So now we are going to find this phi x dash and phi x value. Means if suppose second person, if he calculated the velocity, so let it be he got 6 meter per second according to the second person. Then if you know this one, then with respect to the first person, how the velocity may be looking, how he may calculating the velocity. As we studied, they will not get the same value because they are in the different frame of references and one frame is moving. Okay, so according to that, they should not get the same velocity. So as he got 6 means something difference he will get. So now our job is to find what will be the velocity according to the what? First person, when the second person already calculated that velocity. Okay. So I hope you understood completely the concept of the thing, what we are going to derive. Okay. So now let's start the derivation. So how according to both the observers it will be looking, the velocity will be looking, and that is called as what? Addition of velocities. So that name they given what it is? Addition of velocities. Okay. So now let's start this one. You know velocity means what? Yeah, velocity is nothing but the rate of change of displacement, isn't it? So it is the rate of change of displacement is called as what? Velocity. And in formula, in like a formula, how you are going to write? Yeah, you will be writing like, say, as I know, I will write here, phi x, comma, phi y and phi z. Be the velocities, be the velocity of a body, be the velocity of a body calculated by a person in S frame, in S frame with respect to what? Yeah, with respect to x, y, z axis, with respect to x, y and z axis. See, as I gave the concept here, he is the first person who is there in the S frame. So when it is moving, he will calculate the velocity. When it is moving, the terminals are changing, the coordinates of points are changing with respect to x axis. Okay, so now with respect to x axis, he will calculate the velocity of a body and he named it as what? Phi x, that is phi x. And at the same time, what will be the velocity of a body with respect to y axis? Okay, so that he will name it as y. phi y, and with respect to z axis how his velocity will be changing, and he will name it as what? Phi z. Understanding? So phi x is the velocity of a body with respect to s frame in s frame with respect to x axis in s frame. Phi y is the velocity of a body in s frame with respect to y axis, whether phi z is the velocity of a body with respect to z axis in the s frame only. Okay, so in s frame with respect to x axis the velocity is phi x, with respect to y axis the velocity is phi y, and with respect to z axis the velocity is phi z. Okay, and at the same time the second person will also calculate the same velocity. Okay, then according to him the velocities are given by phi x dash, phi y dash and phi z dash. Okay, so that is be the velocity of a same body, be the velocity of a body calculated by a person who is there in a S dash frame. When he is in S dash frame, he calculated again with respect to what axis? So for S dash frame the coordinates becomes x dash comma y dash and z dash axis. So with respect to this axis they calculated the velocity. So that is phi x dash, phi y dash and phi z dash. Okay, now the thing we are going to derive that thing. Okay, so already you know the velocity means let it be phi x. So the velocity is nothing but the rate of change of displacement. So how we will write? Phi x is equal to, you will write dx divided by dt. At the same time what is phi y? Phi y is dy divided by dt. And what is phi z? Phi z is dz divided by dt. Okay, so phi x value of velocity with respect to x axis dx by dt, with respect to y axis dy by dt, with respect to z axis it is dz divided by dt. Now with respect to s dash frame same velocity we will calculate along a 3 axis. So what we will get? We are getting phi x dash is equal to dx dash divided by dt dash, and phi y dash is equal to dy dash divided by dt dash, isn't it? And phi z dash is equal to dz dash divided by dt dash. Okay, so this is all these three velocity are with respect to what? S frame, with respect to S frame, and these are velocity along the three different axes with respect to what? With respect to S dash frame. Okay, so I hope you understand this. Now the next thing we will take again the Lorentz transformation equation, because Lorentz only gave how the thing will be changing with respect to S axis and with respect to S dash frame. So to know that again we should take the Lorentz transformation equation. So what is the Lorentz transformation equation? As we know we will get x dash is equal to position x dash is equal to, we are getting x minus phi into t divided by square root of 1 minus phi square by c square. This is the Lorentz transformation equation. Means x dash is the position of that body with respect to what? S dash frame, where the x is the position of a body with respect to what? S frame, and t will be the time, and phi be the velocity of a moving frame, where the c be the velocity of the light. Now this is the x dash value we got, and in our case also whether the body is moving along the x-axis only. Okay, so when it is moving along the x-axis there is no change along the y-axis as well as z-axis. Okay, so if it is the case, then what would be the value of y dash? Value of y dash will be what? Y only we will get. At that same time what will be the value of z dash? Z dash is equal to z, because there is no change along the y and z axis. The body is moving only along the x axis. And last one is t dash, because time will be changing. So whenever a body is moving, if he calculated the time, how much time it had taken to change the position, with respect to S dash frame, the observer who is there in the S frame, he will not get the same time as the second person calculated. Okay, so that's what time also changes. So for that, the time will be given by what? According to Lorentz equation, that is t dash is equal to t minus v by c square into x whole divided by square root of 1 minus v square by c square, isn't it? So this is the what? T dash value. So now we got x dash value, y dash value, z dash value as well as t dash value. So now I'll go to this equation. I'll take this equation. Okay. To find this velocity, is it the necessary of dx dash and dt dash? Because if you know these two values, no, then only you are able to calculate the vx dash value. Then the question is how to get the dx dash value and how to get the dt dash value. So for that, shall I take the Lorentz transformation equation? Because already x dash value we know, something we are having. So this one only we can change it as what? Dx dash. Okay. So when we will change in terms of dx dash this value, so how we are getting? Yeah, you are getting a dx dash is equal to, as x dash becomes a dx dash means x become dx minus v will be as it is because it will not change. The moving frame having this constant velocity, and time changes. Time changes to what? dt, and what is remaining? The remaining term is divided by square root of 1 minus v square by c square. Okay, and this is the dx dash value got. And what will be the dy dash value? Okay, so dy dash is equal to, you will get a dy. Comma, what is the dz dash value? We will get dz dash is equal to dz. And what is remaining? T dash. In terms of dt dash we want. So what would we have get? dt dash is equal to dt. T becomes a dt. Minus v by c square as it is into x becomes what? dx. And whole divided by square root of 1 minus v square by c square. Understanding? See, this is in terms of x dash we are having the equation. When x dash becomes a dx dash, no, x becomes a dx. V will be as it is because the velocity is constant, and t becomes a dt. That's what the thing. Same way, y dash when it becomes a dy dash, no, y become dy. Z dash when become dz dash, no, z becomes a dz. And last, t dash when it become dt dash, no, t become dt. Again x becomes a dx. So in terms of change in position and change in time, we got the equation. Okay. So lastly, I'll prove this one. I'll calculate these velocities, all the three velocities. So first I'll take the equation. That is the equation. What we are having equation? Vx dash is equal to dx dash divided by dt dash. This is our main equation. And this is equal to, now we are having dx dash value here, and also we are having dt dash value here. So shall I substitute these two values here? So what we will get? You are getting dx dash value is dx minus v dt. Here it is there. Whole divided by square root of 1 minus v square by c square. And this is whole divided by dt dash value. So what is the dt dash value? Here it is there. That is dt minus v by c square into dx whole divided by again square root of 1 minus v square by c square. Okay. So just I substituted the dx dash value and dt dash value. Then whether is it will cancel with each other. So both are cancelling here. So if they cancelled, then what you will get? You are getting vx dash is equal to dx minus v into dt divided by dt minus v by c square into dx. So this is the equation you got by cancelling in numerator, in denominator. Both are same terms. So I cancelled with each other. So now what I'll do, I'll make certain rearrangement to this equation. Okay, and that rearrangement is nothing but the whatever the numerator and denominator is there, I'll divide by dt. on both the side. Here also divided by dt and here also divided by dt I will make. So if it is divided by dt, then how it will be looking? I will write this is whole divided by dt. For both the terms it is coming divided by dt. So what we will get first? Yeah, dx divided by dt minus phi into dt is there, again divided by dt. Yeah, dt will be dividing both the side. In the same way, whole divided by what is there in the denominator? Dt. Again it is also divided by dt. So dt divided by dt minus what is remaining? Phi by c square as it is, and this what we will get? Yeah, again dx divided by dt. See, we divided by dt on numerator and denominator. Just rearrangement I made. Means if you cancel these two, again you are getting the original equation. That's what the thing. Okay. Now this is equal to we know already the dx by dt value. Where we know? Here. So if you see the equation, you will come to know the dx by dt value is what? Dx by dt is nothing but phi x. So shall I substitute here? Dx by dt means phi x. Okay. So I will substitute. This one is equal to phi x minus phi as it is, and this dt get cancelled. Okay. So minus phi only we are getting. Whole divided by, again dt by dt is there. So if they cancel, 1 you are getting. Okay. Minus phi by c square as it is, phi by c square. Again dx by dt value becomes what? Yeah, this is nothing but we will get it as what? Phi x only. Understood? So phi x dash is equal to, we got the equation, that is phi x minus phi whole divided by 1 minus phi by c square into phi x. So this is what the phi x dash value. So in the same way, we should calculate phi y dash value as well as phi z dash value. Okay. So first I will write this equation. That is phi x dash is equal to phi x minus phi whole divided by 1 minus phi by c square into phi x. So this is the equation we got. First equation in terms of what? Phi x dash. Now in terms of phi y dash, what would be this equation? Okay. So again with the same thing I will move. With the same thing I will move. See. As I am calculating phi y dash value. Okay. So phi y dash is equal to what? Yeah, we know the equation. Here is there. Phi y dash is equal to. Okay. So what we will get? Dy dash divided by dt dash. Now which is equal to, what is the dy dash value? Yeah, dy dash is equal to dy. So I will write dy divided by what is the dt dash value? Here it is same value. So substitute. What we will get? Yeah, you are getting dt minus phi by c square into dx whole divided by square root of 1 minus phi square by c square. Is it the equation? Now we will get phi y dash is equal to, okay, phi y dash is equal to, this will go to the numerator because divided by is there. Okay. So when it will go to the numerator, what we will get? Yeah, you are getting dy into square root of 1 minus phi square by c square whole divided by dt minus phi by c square into dx. This is the equation we have. Now for this one also what I will make? I will divide it by dt for numerator as well as denominator. Something rearrangement I made by dividing by dt. So if you divided by dt, then what you will get? Yeah, are you getting? This is as it is multiplying. So for any one you should multiply. See, if it is plus or minus, you will divide for both the thing. This one. But as it is multiplied, only one term you should divide. So that's what we got, dy by dt into what? Square root of 1 minus phi square by c square. We got the equation. Whole divided by, again dt is there. So now as it is minus, this dt will be divided for both the terms. Okay. So what terms first we will get? Yeah, dt divided by dt minus second will be phi by c square into, yeah, dx by dt. we got the equation. Okay, now this one we will write phi y dash is equal to, what is the value of dy by dt? Yeah, the value of dy by dt is nothing but what? Phi y. Okay, so I'll write dy by dt value is what? Phi y into square root of 1 minus v square by c square whole divided by, again dt get cancelled, so what will get? 1 minus, okay, 1 minus v by c square into, what is the value of dx by dt? Yeah, dx by dt value is nothing but what? Phi x. Okay, so it is phi x 0. Okay, now this is the value of phi y dash value. Phi x dash already we calculated. This is the phi y dash value. In the same way, if you go on calculating the phi z dash, no, you will get phi z dash is equal to, where phi y is there, it will be phi z. That's what the thing. The other things will be remaining same, because you know phi z dash is equal to dz dash divided by dt dash, you will get, which is equal to, as z dash is equal to z means dz dash is equal to dz. So here we will write dz, only that is change, but dt dash values remains constant. Okay, so in the same way, if you calculated the phi z dash value, no, so what you are getting? You are getting it is equal to phi y in terms phi z we will have into square root of 1 minus phi square by c square whole divided by 1 minus phi by c square into phi x. Okay, so this is the phi z dash value. Okay, so now from the first thing we had been calculated the phi x dash value. So here you can measure, here you can compare. This is the phi x dash value, phi y dash value and phi z dash value by taking their what? Original equation. So just taking the original equation and adding the thing, we go on getting the what? The different values of phi x dash, phi y dash as well as what? Phi z dash. So this one we called it as what? Addition of velocities. How the velocity will be adding. So starting I told the example that when we are measured, no, with respect to s dash frame the velocity of one body, then with respect to s frame how would we calculate it? So here what the thing we got, already the s frame observer calculated the velocity of that body. So he got phi x value, that one. So if he calculated that value, then with respect to s dash frame how would be the velocity with respect to the s dash frame? So for that this is the equation. So first observer, what the velocity he will calculate, substitute here, minus the velocity of the s dash frame we know already, that you substitute, divided by 1 minus again phi by c square. C means velocity of light, that is 3 into 10 raised to 8 meter per second. That one you substitute into what? Phi x. Already he calculated the phi x value. So only when one first observer already calculated the phi x value, no. So if you substitute in this equation, then with respect to s dash frame, how would be the that velocity will be looking? So that one we will come to know. So this is what the thing. Okay. Now the next. From this, from this we are going to find what will be the inverse Lorentz transformation equation. So inverse Lorentz means what? The opposite to this. Now we calculated the phi x value, phi y dash value and phi z dash value. In the same way, how we will calculate phi x value, phi y value and phi z value? When we will calculate? Yeah, when phi x dash value already we know. Okay, so that one I will tell in the what? Next class. How to identify, how to determine phi x, phi y and phi z from these values. And also we are going to find the second postulates of Einstein theory, the most important thing. Okay, so I hope you understood all the concept. So if any queries are there, so you can to ask, you message me. Okay, thank you.